Hello everyone, I'm back, and in the last video I talked about using a pericarburetor I had for a model airplane engine. I'm going to try it on the V8, Cison V8, and see if it's capable of being a little more controllable on the idle and so forth. Anyway, I'm here in my Fusion 360, and I have already drawn the mounting bracket or block that I have. But I'll show you how I did it. Let me turn on the body, and this is what I'm after to make the finished part. So I will start and show you how I did it. Let's go all the way back here to the first sketch. So I drew up the first sketch here, and this bolt pattern is exactly the same, of course, that as the old carburetor was. It's a 1" by 1" square, and the holes is the same side, and the little tangs that stick out is about the same size. I just added a radius in here, and these things are on like a 10-degree angle out. And once I had it drawn, then I extruded it up to 3D. And this is the same thickness as the Cison carburetor's little foot tabs that stick out. So then I needed a round body sticking up here, so I had a place to mount my pericarburetor. So I drew another little sketch of a circle. This is 0.7 diameter. And I extruded that up so that I would have a total height, if I measure from the top there to the bottom there, of 0.625, which is 5/8 of an inch. Close. So then I needed a hole going through it, I believe is what I did next. I sketched for the hole right up here, and then I cut it on through and down to the bottom. And then I thought this needs a radius right in here, so I added an 1/8" radius here, just like that. And now there it is, finished. So I thought, well, how much of this am I going to cut, or how am I going to make it? And I thought, okay, well, this is easy. This curved part right here is, I'm going to use my CNC router to cut that. It's not very high, and it should be able to cut the aluminum fine. It's not very rigid, so I have to move very slow through here, but it should cut the aluminum just fine. But the rest of it, I think I will make on the lathe. I'll get first of all a big stock. It looks like, after I measured this, it's 1 5/8 diameter. So if I get a bar 1 5/8 of aluminum, then I can turn this diameter down with an 1/8" radius and cut it all the way until I get to this thickness, and then part it off on the lathe. That way it'll leave me a big diameter here, and that will be the part that I'll put on my router and cut just the feet. But in order to do that in Fusion, I need to draw my material, the part that I'm finishing on the thing. Otherwise, it's just going to put a big block of material on here, and I don't want it to be a block. So you have to draw it. You have to draw another model and tell Fusion that that is the material. And so that's what I did. So the next step was to activate another another part of the model here, and I called it material. And let's turn off the body of the main one. So our first sketch was, where is my sketches here? There they are. So my first sketch, oops, I must have turned it off. Yeah. Huh. Oh, the whole material's turned off. That's why. Okay, so yeah, I have a 1 5/8 diameter, and I extruded it up to be the same thickness as those feet were. So you can tell if I turn the main model on, it's right the same. You can see it there and there. So I'm exactly the same thickness. And as you can see, 1 5/8 is just a teeny bit bigger. So that's perfect. As the cutter comes around, it'll clean up nice right there. I'll turn that body off. So I also needed, well, you can see I needed to get this same outside diameter and the radius in exactly the same. So I drew the next circle, which was the 0.7 diameter, and I extruded that up the same. And then I put the radius on it, just like that. And then I went ahead and put the hole on through there. But after I'm thinking about it, because I have to tell my router where the 000 is. And I'm looking at this, and I think I want to indicate off the top in the X and Y, but I normally put the Z at the bottom of the part. So in order for me to find the center, I don't want to have this hole in here. So if I take the hole away, I can then, while it's on the lathe, move a drill point right up here and just touch it a little teeny bit to give me an inverted cone in the part. Then I have that same little I have the same little pointer that matches a drill point in the collet of the router head, and I just have to bring it down and push on this, and it will self align. It'll just self right align down on the table, and then I know I have the whole thing exactly centered to the router. So that's exactly what I'm going to do. So let's turn off the material, turn back on the part, and let's go on over to the manufacturing side. There. Okay, here we are. And yeah, it shows I had to tell it I was using a router, so I used the standard 360 3-axis router. So the first thing you have to do is get a setup going. So let me open up the setup here, edit, there. And I have to tell it what machine the router is, and I've got the generic 3-axis router, and I'm going to do milling, and then the orientation. I had to choose where I wanted the orientation, and as you can see, just like I said, it is right X and Y in the center of the part, and Z is right at the bottom, so it lines up right even with the bottom of the part. And you can see the part I've got here in blue, and there's the material. And I got that by going to the stock section, and I had to pick from a solid. And once I did that, I just came over here and selected my other model, the solid model that I had. And then Fusion said, oh, that's the material he's going to use. Okay, so then I thought, well, I've got to just contour cut this. So I went up to 2D and a 2D contour. As you can see on the little help screen there, it just will trace around the part that you pick, the contour lines. So let me right click here and edit. All right, so the first thing in the contour, it says, what tool am I going to use? And I chose right out of my tool list a 1/4 inch flat end mill. And you can see it here. I have my own drawing I did here of the custom holder that I use on my router and the end mill. It shows exactly how long it sticks out of the end of the holder. And so I also have that tool set up with all the speeds that I cut with. It's got a spindle speed of 10,000, which is the lowest speed my router will turn. And I kept the feed rate, the cutting feed rate, down pretty low at 20, because I said my router is just not very rigid like a milling machine would be. So it should be fine, and I also have control over on the computer down there. I can even slow the feed rate down while it's going if it seems to be shaking too much. Okay, so then the heights. I had to tell it, well, how if my Z is at the bottom and I know I have to go down in the Z to finish cutting this, but sometimes if it can leave a little edge right here if I'm not cutting all the way down. So I told the bottom of the stock was going to be 30 thousandths in the negative, down lower. So if you turn this on its side here, you can see here's the bottom, and the cutter will come down 30 thousandths past it. I'm going to bolt this down to a sacrificial piece of like MDF or some wood so that I can bolt it down and it'll stay right there. So I won't worry about it if the cutter cuts into it. And now, then the passes. Okay, so the first thing it wanted to know was, oh, the geometry. Did I tell you? I forgot. I chose the top line here. I chose the top line as what I was going to cut, and so it went around and chain picked everything, and it shows me the direction of the cutter, and the cutter turns clockwise, so that's a climb cut. The cutter is trying to climb up on top. You get the nicer looking cuts on aluminum if you climb cut. So then the passes here. I told it I wanted 2 finishing passes, or basically in this is a finishing tool pass, so it's just 2 passes. And I told the step over to be 10 thousandths of an inch. So it's got a little step over, and we're only going to get 2 of them. And then I said, okay. And after it looks and calculates it, you can see here that the first pass is going to be out here, and it's going to stay away from the exact part of the model by 10 thousandths. And that way, if it's going too fast and it gets a little rough cut right in here, it doesn't look nice, it has a cleanup pass. This next one, it moves over 10 and then should do a very nice job cutting to look nice around the part. So what's left here is I want to simulate it. I want to see if there's any other problems, and it will tell me if there's a problem. So I go in here and I say simulate. So there it shows me the material that I'm going to use, and I'm going to then say play, and it's going to come down and start cutting in, and you can see how it left a little flat there because it's not cleaned up. There, the second cut actually cleaned it all up, and there, and that would be the finish cut right there, and it's all done. And I didn't get any errors or any problems, so we can exit that. And now all that's left to do is to give me the G-code, to output the G-code. So I'm going to right click here and say create the NC program. All right, and it knows the machine, it just doesn't know the post I want, post processor. And I got Mach 2 mil in here after I got the post processor figured out right. The file name, let's call it V8 Carb Mount, M-O-U-N-T. And then right click and copy, and then we can paste it down here and paste. Okay, that's the name in the program and the actual file name there. So if we say post, there it says NC code created successfully. All right, so we are done here, and on the next video that I do, I will actually be using my CNC router out there, and you can see how I do this. All right, see you later. Okay, I have to get this diameter down to 0.7, so I decided to use this tool. It cuts a little better. This one with the big radius on it that I ground will have to be the last thing I do, and I'll go slower and finish that radius at the bottom. So I've got a ways to go down to get to my 0.7 diameter here, because I'm at 1.52 right now. So yeah, be back when I get down closer. Okay, I'm gonna try to cut the little radius right there with my tool now. I have the lathe turned on fairly slow. Here we go across it. And I'm looking for 45. Right about there. And there's one cut. Let's back it away. And I'll turn it in just a teeny bit more. There. This should be the final cut. And as I get close, let's go look at the number. 45. And there it is. And then we can back it out. That's looking pretty nice little radius right there. Yeah, there's a little bump. I may want to go back in just a little bit deeper and take that bump out. Okay. Okay, I took a little cutoff tool. Can we get focused here? Yeah, right here, you can see. And I went a little bit further than what I needed, because I'm just gonna, this would take forever to cut it off with a parting tool. So I'm gonna take it over to the bandsaw and I can set the blade right. This is a little thicker. Then as I come back, I'll flip this around and hold it here, and then I can trim the face flat and nice looking. Okay. Okay, I finally got it. Here it is. And I almost forgot to put my little cone point, as I talked about, in the thing. But I did remember it before I took it off, and I couldn't put it in my cutoff bandsaw. Standing it up like this to cut it, it just wasn't long enough. I couldn't clamp it, so I decided to put it back in the lathe, and I went ahead and used the cutoff tool. And I took a long time because it sticks out a long ways, and so I just increased it out of the holder just teeny bit at a time and went real slow, and I finally cut it off. And then I turned it around and faced this off so I had the right thickness, just like what it shows there. So, as I told you before, how I can line that up, I have my little CNC tools in here, and one of them is a little pointer thing that I can hook into the router. And even though the cone is a different taper, it still finds where center is. And once you when you put it down into the thing, it'll still find it. So that's all I got to do is drop the thing down, and it'll do it, and then clamp this once it's there. Okay. Anyway, yeah. So, and then I said I'd use the 1/4 inch. No, this is the 1/4 inch flat cutter I'll use. So these are my fixed tooling I made. I turn each one of these if I need a new holder, and then I keep them in here, and the length is set in the software, you know, the tool offset length. See, so I've got them all the way down to like an 1/8 of an inch and all different kinds in there. I had a real long one I had to have once, so I had to make a special long taper to hold this guy. Okay, so next thing I'll be putting it on the CNC router, and we'll do our little shape around here and cut it.